What's up, amazing people, viewers, subscribers, lovers of chemistry out there? I'm super excited to be here with you on this final episode on this series that we've been having on acids, bases, and salts. And here on this final episode, we want to look at some of these common misconceptions that students and people generally have about acids, bases, and salts. So, without any further ado, let's go into what we have for today's video. Now, the first misconception people have is about acids, and many people believe that acids are all dangerous liquids that burns everything. In fact, students think that acids are scary, they burn your skin, and they melt stuff just like in cartoons. Now, that is true, but it doesn't apply to all acids. In fact, if you look at the bottom right corner of your screen right now, you'll see I have the image of some food substances that we eat, and they contain an acid that is known as the omega 3 fatty acids. So, even though most acids are actually corrosive and they burn stuff, it is not applicable to all. Not all acids are actually dangerous. Some are actually safe enough to eat, which brings me to the first example of such acids. The first example we have is known as citric acid. Now, citric acid is a kind of acid that is found in citrus fruits. Those are fruits like oranges, lemon, and what have you. So, lemons, oranges, and the juices that come out of those fruits contains the acid that is known as citric acid, and it is absolutely harmless. The second example of a mild acid that we have is vinegar. Vinegar is a substance that contains an acid that is known as acetic acid, which is used in the kitchen for adding flavor to food. And that brings me to the third example of a harmless acid that we have, and that's carbonic acid. Carbonic acid is a kind of acid that is formed when carbon dioxide, also known as CO2, is dissolved in water or in a liquid. And it is contained in many of the soft drinks that you have. We call them carbonated soft drinks. Now, those drinks that when you open them, they make this fizzy sound, you know, that is indicating that there is a gas that is escaping, and that is the carbon dioxide gas. Drinks like your Coca Cola, Fanta, Sprite, and all those drinks that make a fizzy sound when you open them contain carbonic acid. So basically, you drink acids in soda and you eat them in fruits. So now that we've cleared the first misconception, let's go over to the next misconception that students and people generally have. And that misconception is about bases in this case. You see, many people believe that a base is a substance that feels slippery. If it feels slippery, then it is a base. If it doesn't feel slippery, then it is not a base. The truth is, actually, many bases actually feel slippery and are soapy, like soap and bleach. But not all bases feel that way, especially when they have been diluted or when they are in the solid form. Also, it is important to note that touching bases or chemical substances generally is not always safe. A very good example is sodium hydroxide. Sodium hydroxide is a very strong and corrosive base. Now, corrosive simply means that it will irritate or burn the human skin when it comes in contact with it. Okay, so never you test a substance by touching it with your bare hands. Use indicators instead, and we have made a video talking about the different indicators that you have in chemistry. So you can go ahead and check them out. So now that we have misconception 1 and 2 out of the way, let's proceed over to misconception 3. The third misconception that people and students have generally is that salt is only white substances that you put on food. Many times people think salt is what we sprinkle on our food, like rice, on our fries, and it is white and tasty. Yes, that's true, but it is just only one type of salt, sodium chloride, which is the table salt that we use in our houses. The truth is, there are many types of salts that are made from different acids and bases. Now, let's do a bit of backtracking for a minute. If you remember in one of the videos that we made before this one, we said that a salt is the product that is gotten when an acid and a base react. And when an acid and a base react, it is called a neutralization reaction. And a neutralization reaction produces salt and water, which tells us that there are different types of salts that we have. The first example is the most common, sodium chloride, and it is made from the acid hydrochloric acid HCl and the base sodium hydroxide NaOH, and it is used as table salt. The next example of salt that we have is the potassium nitrate salt, KNO3. And this salt is made from acid, nitric acid, and potassium hydroxide. Okay, so when the base potassium hydroxide reacts with the acid trioxonitrate 5 acid, it is one of the things that are produced is the potassium nitrate salt, and it is actually used in the production of fertilizers and fireworks. Which brings us to the next example of salts that we have. And I hope you're seeing at this point that the table salt you use in your house is not the only example of salts that you have. There are different examples that we have which we use in our day to day life. The next example is calcium sulfate. Calcium sulfate is a salt that is made from the reaction of H2SO4, that is hydrogen tetraoxosulfate 6 acid or sulfuric acid, and calcium hydroxide base. Now, when the two of them combine, they make up a salt that is known as calcium sulfate. And calcium sulfate is a salt that is used in the production of plaster of Paris, which we know as POP. Now, the next and final example of salts that we have is the ammonium chloride salt. Ammonium chloride salt is made from the hydrochloric acid and ammonia and hydrochloric acid. When the two of them combine, one of the salts that is produced is ammonium chloride. And this is used in the production of dry celled batteries and in the production of drugs. So you can see basically salt is not just a flavor, it is a chemical family. So now that we have been able to knock off three misconceptions among the many misconceptions that people have about acids, salts, and base, it is time to draw the curtain on this series and on this episode. I want to say a very big thank you to each and every one of you who have engaged with me thus far on this space. It's a privilege to serve you with my gifts, potentials, and all that I've got. I want to implore you to please subscribe to this YouTube channel, like this video, and turn on the notification bell icon so when more bangers like this come out, you'd be the first to be notified. Until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I'll see you in the next video.